Hello and welcome to another video of Grokking the Coding Interview series. In this video we are having a look at the sliding window pattern. My name is Parth and let's get started with today's problem, which is the maximum sum subarray of size k. Let's have a look at the problem. Given an array of positive numbers and a positive number k, find the maximum sum of any contiguous subarray of size k. And here we have an example where k is 3, so we essentially have to see what is the maximum sum in every subarray of size 3. And here we see that the maximum sum is 9 and it comes from this array. In addition, we have another example, which is this array, and the k is 2. We see the maximum comes from 3 and 4. Okay, so how would we go about solving this problem? We saw previously that in sliding window pattern, we have, instead of doing the calculation, so for example here we could essentially go ahead and take all the windows of size 3 starting from here, then move here and so on, and calculate the sum and keep a track of the maximum. And this is one way of accomplishing it. However, in sliding window we have a fixed length of window. For example, here we can take a window of size 3 and essentially we can move this window forward, and we, instead of doing the calculation again, we can simply remove this element from the window and add the other element into the window. And of course, like in this case, the window size is fixed, but eventually, as we'll see in other examples, we can also shrink and expand the window as we do our exploration. So how would we go about solving this problem? Let's try to have a simple working example and see if we can produce a solution here. So essentially what we need is the max sum. So we want to keep a track of the max sum. We want to keep a track of the window start. Like window start will be a handler of how we are moving the window forward. And we also want to keep a track of the current sum. Essentially we'll initialize all these to 0. And as at this stage, what we want to do is we want to iterate through the array, and the way we do it is for window end in range length of array, and this essentially means that we are trying out all the elements. So initially our window start and window end are overlapping here, so it's 0 0, and gradually we are expanding window end. So and here is what here is where we have to focus on a very important dimension, which will be a condition of how our window behaves. So at this stage, of course, we want to go ahead and add the current element from the window end into the sum. However, we want to put in a condition where we do some checks. So in this case, we want to check if window end is more than or equal to k minus 1. It would essentially mean that we have reached or the distance between the window start and window end is k now, which is what we wanted. So we wanted our window length to be k, and at this stage we can start incrementing the window start so that we iterate through all the windows of size k. Okay, so once we have met this condition, the first thing we want to do is we want to see if our max sum is indeed the max, or the current sum is greater than the max sum. At the same time, we want to reduce the current sum. So essentially, we are removing the window start from the current sum as we are moving the window forward, and we also want to update the window start. So we are doing this index increment at this moment, and this should give us the answer we are looking for, which is the maximum sum across all the windows of size k. So let's have a look at if we have the answer we are looking for. Just as a sanity check, let's do a quick dry run and see if things are as we expect. So we have the max. We start from 0, go until the end of the array. We keep adding the element to the current sum. We see if the size of the window is equal to k. If it is, we check if the maximum sum can be updated. We remove the start element as we are moving the window forward from the current sum, and we also increase the index here, and it should give us the answer. Let's have a look if we meet the conditions. Yeah, so it seems like we do have the correct implementation. So let's speak about the space and time complexity of the implementation. Essentially, when it comes to the time complexity, we are just iterating to the array 1, so it will be O of n. And when it comes to the space complexity, we are not actually storing anything. Let me quickly check. So what is yeah, so the space complexity is the constant space. Okay, so this looks like, so the time complexity is O of n, the space complexity is constant space. I hope you found the explanation clear. Please let me know in case I can improve on that one, and until the next video, have a great day.